Hello, and I have all my settings healthy this time. So, hello and welcome to the Daily Space for Monday, June 4th, 2018. As always, I am your host, Dr. Pamela Gay. And as always, I am here to bring you a daily roundup of all that's new in astronomy and space science. Now, our timing of this particular stream today is not ideal. Right now, the American Astronomical Society is having a meeting out in Denver, Colorado. And at their meeting, they are thank you so much for the follow. So right now out in Denver at the meeting of the American Astronomical Society, they have, starting probably 1 minute ago, a press conference on minor bodies. So it turns out they're starting their news the same time we're starting our news. So there may be an update later today at the end of the first day of the American Astronomical Society meeting. Now, I will be working to try and cover as many of their press conferences this week as I can, and I will be bringing you updates as I can. Now, also starting right now is the Apple Worldwide Developing Conference keynote presentation. So I'm going to do what I can to keep this short because I need a new laptop and want to know what my options might be. So it turns out that sometimes the news just falls out of the sky, and this weekend there was a whole lot of news falling out of the sky. The first thing to happen was a fireball over China. On June 1st, there was an amazing, I'm hearing reports of a bolide. Thank you so much for the follow, Grisha. There was a bolide that entered June 1st over China. This was over a village in the province of Menghai County. And this particular fireball, this particular bolide, call it what you will, it did things like go through roofs and leave clear little carbonaceous remnants kind of all over the place. Now, this has led to a great deal of confusion on Twitter because on June 2nd, in the morning, there was a discovery by the Catalina Sky Survey of asteroid 2018 LA. Now, this has nothing to do with Los Angeles. The way we name asteroids is that first letter A, B, C, D, E, F, G. Well, this L stands for the first half of the month of June. A means this is the first asteroid found in the month of June. So asteroid 2018 LA was discovered on the morning of June 2nd by the Catalina Sky Survey, and it was discovered to be on a collision course for the planet Earth. Now, this wasn't actually too big of a concern because this particular asteroid is only 2 meters or about 6 meters across, 2 meters or about 6 feet across. You may know sofas bigger than this particular rock. Now, the fact that we were able to even discover it, I personally find kind of amazing. These astronomers very quickly ran calculations of just where the asteroid might impact our atmosphere and told people to go out, look up, and be prepared for an impact at 10 miles per second. This is 38,000 miles per hour or 17 kilometers per second. So with this particular fireball, we actually have video thanks to security cams in Botswana. So here is what was observed. And more video, I'm sure, will become available throughout the day as people go ahead and pull down to see what they have. Now, where this is creating confusion is I have seen a few very confused tweets where people are combining these two events, where they are saying that there is an impact predicted along a particular path across the Earth, and all of these individuals in the Chinese village are mistaken in thinking that they have asteroid or meteorite bits, and they're just trying to get rich off of this. This isn't actually the case. There were two completely different events. June 1st over China, June 2nd over Botswana. So sometimes the sky does fall. Now, when asteroids aren't falling to Earth, whether they be big or little, we have many other things going on in our solar system. Looking out beyond, we see this artist's rendition of a wildly star-forming galaxy. This is what's called a starburst galaxy. A group of astronomers that were observing not just this artist's rendition of a galaxy, well, they didn't observe the artist's rendition. In addition to observing the galaxy that this rendition is based upon, a number of different starbursting galaxies in the early universe were observed by a team of researchers that are trying to find ways to disentangle exactly how stars form in these different systems. One of the big questions that astronomers have in understanding star formation is the ratio of big to little stars that we have forming over time. It is generally believed that what we call the initial mass function, that initial range of masses that stars form in, is pretty much the same with some variations based on known variables occurring in known ways. We thought we understood the initial mass function, past tense. It turns out we were kind of wrong in some of these systems. This particular team of researchers, in using the ALMA radio telescope, they were able to look out, and they also used the very large telescope, so they looked at a variety of different wavelengths. And what they went looking for was the ratio of oxygen 18 to carbon 13 atoms that they could observe in spectra of these systems. It turns out that oxygen 18 is produced primarily in the most massive stars, whereas carbon 13 is produced in more low to intermediate mass stars like our sun. By looking at the ratio of these two elements observed in these starbursting galaxies, they were able to use these as probes for the ratio of massive stars to intermediate and low mass stars forming in these systems. What they found was in these starbursting galaxies, it turns out that there's a significantly higher production of massive stars than we see in our own Milky Way. Now, what is frustrating is this challenges our ideas of how stars form. They also looked at a star-forming region nearby. So it turns out that when you have starbursting galaxies, whether they be in the local universe, 13 billion-ish years after our universe formed, or early in the universe, which we thought might be the dominant factor here, these starbursting galaxies just form more stars. Whereas peaceful galaxies, things that are less active, have less star formation going on, we see more lower mass stars. So it turns out environment really does matter if you want to form big stars, little stars, and we still have a lot to figure out when it comes to forming stars. Now, not all news was so out of this universe or so violent as our star formation and our asteroid impacts. In completely underwhelming news, a group of researchers who have studied a whole suite of galactic globular clusters. These are clusters of, stars that for the most part formed at the same time and out of the same blob of gas and dust. These particular clusters that they observed don't seem to have the intermediate mass black holes that we were hoping to find in these systems. There is a fundamental plane describing how various spheroids behave, their mass ratio, their velocities. And there was a thought that in these globular clusters, we would start to find black holes that are 1,000 solar masses and higher. In looking at these 50 different systems, they just didn't see it. They were using the Australia telescope's compact array and looking for the telltale signals of, well, the radio signal that comes from having a black hole. We see this with our own Sag A star in the center of our galaxy. We see these radio signals coming from other nearby galaxies from their supermassive black holes, and we hoped we'd see the same sort of radio emission here in these globular clusters related to a intermediate mass black hole, and this was not to be seen. Now, this could be explained if there wasn't sufficient gas present in the cores of these globular clusters to interact with the central intermediate mass black hole, if it existed, and to produce this radio signal that was being looked for. However, these globular clusters are rich in red giant stars, which are actively undergoing mass loss, and that mass loss provides the gas that is needed for these intermediate mass black holes to, be associated with radio emissions. Now, there are systems out there that we think have intermediate mass black holes, but these are all low signal to noise detections. So time will tell if any of the prior observations of systems that were rumored to have intermediate mass black holes turn out to be true. Once again, it's a case of what we thought was true, well, just might not be. And it just might not be that intermediate mass black holes in the center of globular clusters are a thing. Now, this is all that is new and interesting to report as of half an hour ago. As I said, right now we have a press conference going on over at the American Astronomical Society, and today is a day that you just might want to put yourselves on Twitter and follow along on the conference hashtags. So check it out, and I will be here tomorrow bringing you more of all that's new in astronomy and space science. Now, before I go ahead and take questions, I'd like to let you know that this is a production of CosmoQuest. We are part of the Astronomical Society of the Pacific, a 501c3 nonprofit. We are made possible thanks to, your subscriptions and your bits and your donations. We are basically made possible thanks to you. So please, if you like what you see, give us a follow and help fill your brain with science. If you want to sustain our efforts, every subscription and every bit helps. Now, once again, this has been The Daily Show, brought to you by CosmoQuest. I will be back here, or one of my team members will be back here every Monday through Friday that is a work day, bringing you this news at 1 p.m. Eastern, 6 p.m. London, and that is, that's 10 a.m. Pacific. So thank you, and I'm here to take your questions. Thank you for the bits, Keeper of Maps. That's awesome. So do we have any questions, or is everyone currently waiting to go run off to the Apple Worldwide Developers Conference keynote? And Keeper of Maps, you are always such a sustainable fellow with your twinkly bits. I'm not seeing questions today. It is a quiet house. There's 40 of you out there. Someone has got to have a question. This is, after all, one of your rare chances to be face-to-face with an astronomer, even if it is through the internet. So I see Paranor asking, could Sol have seeded Earth with the proper carbon for life? So it would have been prior generations of stars that seeded our world with carbon. Carbon is generally made in stars, the mass of our sun, in bulk. When these stars die and puff off their atmospheres, they give up some of their elements to the surrounding well, the surrounding universe, and that material gets recycled into the next generation of stars. When people say that you are star stuff, what they're actually saying is you are dead star stuff. We're made from material given off in the death throes of a star's existence. It's a little bit disturbing. So Silent Searchlight is saying, so might either of these meteorites seem reminiscent with the Peekskill meteorite from the early 1990s? I think it's probably too early to tell. Let's stay tuned and see what is found and just what the people with the microscopes and the slicing devices find under the telescope. We are dead star stuff. We are totally dead star stuff. So Dragon Nation, if you can at me, it's easier for me to find your questions, but I did find yours. If the Earth was compressed to the size of a golf ball, would it become a tiny black hole? Yes, but it would take a whole lot of force to do that. So our planet, if compressed down to about 3 centimeters across, will be a black hole. Now, there is no reason to believe that will ever happen to our planet. We do not have the capacity to do that. So yeah, it's just a fun thought experiment. But what is kind of interesting to think about is there are those who believe that early in the universe's formation, there were physics that occurred that may have generated microscopic black holes that all would have evaporated by now. It's just cool to think that once upon a time we could have had these black holes small enough to fit down between the particles on the planet Earth. So Larry is asking, is there a demarcation between asteroids and meteors? So technically, if it's a rock in space, it's an asteroid. If it's a rock going through the atmosphere, it's a meteor. If it's a space rock that has hit the surface and been picked up, it's a meteorite. So asteroids orbit the sun, meteors interrupt atmospheres, meteorites sit on the surface of planets. That's true, Guido. We did see Alan Stern was tweeting about how New Horizons has woken up. It's been slowly waking up for several days. It sent out an all good message last week. They are preparing for another encounter with another Kuiper Belt object. So I don't know what you mean by an ice meteorite. Art is passion. Are you talking about the meteorites that get found down on the ice in Antarctica? Because those are just like regular everyday meteorites, but they're easier to find because they don't like get harmed when they hit glaciers, and as glaciers melt, they reveal meteorites. So perhaps the one and only good thing that glaciers are good for, given climate change and the destruction rather than the growth of glaciers, is they are now revealing meteorites we can go pick up. Otherwise, any blob of ice would be destroyed going through our atmosphere. So I think a meteoroid and an asteroid is just a continuum of objects, and people who like to define things go with the fancy term meteoroid for things orbiting the sun. But the reality is meteoroids are just like a kind of asteroid. Yeah, I usually just go with space rock. It's a little bit clearer to understand. So Dragon Nation is saying, would that Earth the size of a golf ball still have the same gravity it has now? So gravity is a weird thing. Gravity is a force, and the acceleration that force is able to pull on us, our keys, my iPhone that keeps falling off of counters, that pull of gravity that we experience is directly related to how far we are away from a center of mass. So if you were 1 Earth radius away from that new black hole, so if you were about 6,400 kilometers up, Yeah, the acceleration of gravity would be exactly what we experience right now. But what makes black holes, well, black holes, is because they're so dense, you can get much closer to their center of mass. And it's that ability to get closer to the center of mass that allows you to experience a much stronger gravitational acceleration. It allows you to experience a stronger gravitational force acting on your body. And it causes the object to have a much higher escape velocity. I think the escape velocity at the surface of the planet is, I want to say it's just under 15 kilometers per second, but I'm having one of those mornings of I can't totally remember which unit is which for escape velocity. So with that escape velocity at the surface of the planet Earth, that fights against the gravitational force we accelerate at the surface of the Earth. Well, if you squished the Earth down to 3 centimeters across, and you measured the escape velocity at that new surface would have an escape velocity of the speed of light. And since we can't go that fast, nothing can escape a black hole. So it's all about how far away you are from that center of mass. When you have an Earth-sized mass, stay at least 6,400, 6,500 kilometers away from its center. Okay, scrolling down. Asteroids is referring to the press conference webcasts. I'm glad I was able to explain it, Dragon Nation. Yes, Pluto is essentially a giant comet. I once heard it phrased beautifully by Mario Livio from the Space Telescope. He said that if you took Pluto and you put it in Mercury's orbit, it would become a comet, and that's no way for a planet to behave. Now, there's a chance that once you melted off all those volatiles, once you melted off all that water ice, all of that nitrogen ice, thank you so much to Bitagy for all of the bits for science. That's awesome. Thank you, thank you, thank you. So anyways, what Mario Olivia was saying was if you took Pluto and you put it in Mercury's orbit, it would grow a tail, it would be a comet, and that's absolutely no way for a planet to behave. Now, if you did melt down Pluto, melted off all of its frozen nitrogen, melted off all of the dry ice, melted off all those other things, you'd get left with a rocky core. I don't know the mass of that rocky core. I don't think it would be quite big enough on its own to count as, well, a planet anymore. So, yeah, what happens when you melt a world? This is a question I have. Is it still a planet after you heat it up? Does that need to be part of our definition for a planet? I'm not sure, and I'm glad I don't have to try and write that new definition. I just know the definition we have right now is kind of problematic because it doesn't rely on the geophysical characteristics of a world in defining if it's a planet or not. So, yeah, that's the way it is. So do we have other questions out there? Rock becomes magma. That is true, but rock at the distance of Mercury away from the sun is capable of being solid. So the problem is if we put Pluto where Mercury is, we'd get potentially a potato of an asteroid because everything else would melt away. This is one of the things about the inner worlds is we formed close to the sun. The early heat from the angry young sun actually baked our worlds dry. It was the impact of meteorites that left behind the water that we now have. It's true, magma becomes rock too. And thank you, Art is Passion, for the bits. That is fabulous. So yeah, there's so many different things to consider when trying to decide what is a world, what is a planet, what is a moon, what is a space potato. Thank you for the birthday bits. I guess we have been around for one solid month, but I'm not sure you knew that. So I'm going to take that cupcake as a happy 1 month of the daily space. It's amazing how long we've been doing this, I guess. Other news to share. So here at CosmoQuest, we produce a variety of different content. In addition to the daily space here on Twitch, we are also in association with Astronomy Cast at astronomycast.com, which is co-hosted by myself and Fraser Kane, who's the publisher of Universe Today. All of you should go check out universetoday.com. We are actually nearing the 500th anniversary of our podcast. This does not mean we've been around for 500 years. That would be horrifying. What this means is we are going to be recording our 500th episode in September. In order to better celebrate this, the Weekly Space Hangout crew are good friends who really support everything we do across Universe Today and CosmoQuest and Astronomy Cast. They are hosting a 2-day celebration here in Edwardsville, Illinois, where it is cheap to visit. So if you want to come out and join us for September 15th and 16th, you'll get to meet me, Fraser, in person. We are going to be holding events on Saturday, largely at a brew pub. There will be a star party, weather willing, in the evening. And then we'll be recording the event live at a local art house cinema on Sunday, September 16th. So yeah, check it all out and check out the Weekly Space Hangout crew. They're a really good group of humans. All of our mods get drawn from the Weekly Space Hangout crew. And I just like to say a special thank you to all of our mods out there, because I would not be functional without you. I'd like to do a special shout out for Paranor, who is on top of keeping my Q&A. Well, when I miss questions, they bring everything to attention. On the internet, you have no gender. And then also, I'm really bad about remembering to change the titles, and Paranor's out there changing my title for me on a regular basis. So thank you, mods. Keeper of Maps, you have wielded the banhammer like a true titan, and thank all of you for your help, mods. You're fabulous. Thank you for all of the bits, you wonderful humans. And if I don't see any more questions, I am going to go contemplate if Apple is going to come out with a computer I want to buy, because astronomy software, it turns out, all runs on Macs. It doesn't run on Windows. So yeah, I'm a Mac kind of girl. Yeah, new computer hype. I have totally been saving for this computer for ages. Oh, and happy birthday to Nancy Graziano, one of our original mods over on Astronomy Cast. She started out with a simple message of, it looks like you need help with your Facebook group. Can I help? And I said yes. And it's all been a fabulous journey ever since. And Nancy is the founder of the Weekly Space Hangout. So everyone, if you're in the WSH crew Slack, go give her a big birthday shout out for being amazing. I just might be buying an X.0 version, Larry. I normally don't do that, but sometimes I have to. So thank you so much. I'm not seeing any more questions. So I will be back tomorrow, same bat time, same bat channel, here on CosmoQuest X on Twitch. Come check out the daily space. We will be starting at 1 p.m. Eastern, 6 p.m. London, 10 a.m. Pacific. The Daily Space is brought to you by CosmoQuest. We are part of the Astronomical Society of the Pacific, a 501c3 nonprofit. Give us that follow so that you get a reminder when we're going live. And again, we are sustained thanks to your subscriptions and bits, and every bit helps. So thank you all, and I will see you tomorrow. And wherever you are in the world, remember to have an amazing morning, evening, or afternoon. And sometimes go out and look up. Thanks. Bye-bye.